Okay, hi everybody. Welcome back once again. Today we're gonna be doing counting principle, and it's the new edition. We're gonna be focusing on the not rule. Let's just get straight to it. All right, everybody. Let's just quickly take a look at this conceptualization example before we dive straight into the not rule. Okay, let's say for instance I have a jar that contains 10,000 Smarties, right? Different colors. We have white, we have red, we have yellow, green, purple, pink. I see a lot of different colors there, right? What if I ask you, what's the quickest method you can use, or rather, how can you count the Smarties that are not red? How can you find the number of Smarties that are not red? Okay, I want you to just pause this video for now and think about what you do. If I ask you how many Smarties are not red, what's sort of like an easy way to count? I know a lot of you might be confused now thinking, oh, 10,000 Smarties. How can I count those that are not red? Possibly some of you thought about this, right? It appears that it would be very hard for us to count those. But have you ever thought about what if we start by counting those that are actually red, right? I think that will give us some kind of an idea. If we know those that are red, we can basically go and find those that are not red by simply going to the total number of Smarties and we remove those that are red. Then we get the number of Smarties that are not what? That are not red. Okay, so basically we just say, oh, we know the total number of Smarties, 10,000. I'm looking for those that are not red. Instead of me separating them and all that, trying to count those that are not red, it would take me a lot of time. I can simply do it by saying, let me simply count those that are actually red and then go to the total Smarties and remove those that are what? That are red, so that I'll be left with those that are not red. Okay, this is quite very much related to the not rule. Okay, let's just quickly look at this example. All right, delegates of the BRICS summit are to be arranged in a row of chess. In how many ways can 3 members from Brazil, 2 from Russia, 3 from India, 2 from China, and 4 members from South Africa be arranged such that those of the same nationality do not sit together in a row? And I've just highlighted that in red because it's a very, very key restriction and something we want to learn in this lesson. Okay, let's think back to the Smarties example that I gave you. How were we able to count the number of Smarties that are not red? By simply going to the total number of Smarties, then I remove those that are actually red. Then I found those that are what? Not red. The same idea applies to this problem. We want to count the number of different arrangements that are possible if we are to arrange these people in a row of chess such that those of the same nationality do not sit together. Do you get an idea of how to do it? Yes. We can go and simply count the total number of arrangement without any restriction. Then from the total number of arrangement, we remove those arrangement where these people actually sit together per nationality. Then we'll get those number of arrangement where they what? Do not sit together in a row. And we call this the not rule. Because it's going to be very hard for us to actually count using counting principle the number of ways at the same time in which they can not sit together. So we basically use the not rule, which is like a reverse. You count the opposite. They said count how many different arrangements are possible if they're not gonna sit together. And what we can just basically do is we simply count those arrangement where they actually sit together. Then we go to the total number of arrangements. Okay, total number of arrangement. We remove those arrangement where these people will sit together. Then we'll actually be left with the number of arrangement where they do not actually sit together. So we call this the not true. Okay, let's go and count. All right, we're gonna start by counting the total number of arrangements. Okay, so in order to count the total number of different arrangements, in this case we are arranging different people, so we must know the total number of items or people that are to be arranged. Okay, so in this case we were told that we have 3 members from Brazil, right? So we have 3. We have 2 members from Russia plus 2. Then we have 3 from India plus 3. And we have 2 from China plus 2. And we have 4 members from South Africa plus 4. Okay, how can I count the total number of different arrangement? I just simply count the number of objects that are there to arrange. In this case, it's people. The number of people that are to be arranged, there are 3 plus 2 plus 3 plus 2 plus 4, which is around 3 plus 2 is 5, 3 plus 2 5, 5 plus 5 10, 14 different people, right? So we have a total of 14 people. In how many different ways can we arrange 14 people? In 14 factorial ways. All right, so it's simply 14 factorial. Remember, we use a factorial notation in order to count the number of different arrangements for different objects, items, or in this case people. So we have 14 people in total to be arranged in a row of chess. We can arrange them in what? 14 factorial ways. So factorial, you just use your calculator. Okay, so on your calculator, 14 factorial will give us 8,7 times 10 exponent 10 different what? Arrangements. Okay, it's quite a lot. If I have 14 people in total, the total number of arrangement I can make, it's billion of arrangement. Sounds impossible, right? But yeah, that's it. Okay, now we can go and count the number of arrangement in which the delegates sit together according to nationality, right? So remember, we had 3 members from Brazil. So these 3 members must be seated together. Let me just do this to indicate that we have 3 members there. These are the 3 members. I'm just gonna put them in one unit as one unit because now in this case we want to count when they are seated together. Okay, so we consider them as one unit. Then we have 2 members from Russia. I'm just gonna put them as one unit in this box. And 3 from India. So we have 3 from India. I'm putting them as one unit there. Then we have 2 from China. 2 of them from China as one unit there. And lastly, 4 from where? From South Africa as one unit there. We have 4 members there. Okay, so we want to count the number of arrangement in which these people are actually seated together, right? So we put them as one unit because it's like they're together. There mustn't be someone from Brazil, Russia, India, China, and South Africa. So there mustn't be sitting, maybe someone from Brazil sitting next to. So we consider them as one unit. They are together. Okay, then we can count. If we consider them as one unit, how many different items are there to arrange? I have 1, 2, 3, 4, 5 items. Okay, so this can be arranged in what? In 5 factorial ways, because it's like we have 5 different units to arrange. They are seated together, they must move together like that if we place them different position. So we consider them as one unit, and we have 1, 2, 3, 4, 5 factorial ways. But remember, inside each unit, these people can sit in anyhow, right? So they can shuffle, they can sit. Someone who's sitting here can also come and sit at the first position there, like that. So they can shuffle. So inside each unit, inside the Brazil, we have 3 people. They can be also be arranged in what? 3 factorial ways. Inside the Russia unit, they can also shift. I can start with this one followed by this, or I can swap. So they can also be arranged in 2 factorial ways. India here, we have 3 people. They can also be arranged in 3 factorial ways. They can shift. Even then China, they can be arranged in 2 factorial ways. And here in South Africa, they can also be arranged in what? In 4 factorial ways. Okay, so that's how we count these ones where they will sit together. Okay, let's go and answer the question now. All right, it was quite a long question, but it's fine. Let's go and answer the question. The question needs how many arrangements are possible if those of the same nationality do not sit together in a row. So we are using the not rule here, right? We have actually counted the total number of arrangements. If they sit in anyhow, then we are going to do what? To remove, just like we did with the smarties, to remove those where these people are together, so that we'll be left with those where they are not what? They are not seated together. So the final answer, let me say arrangement, number of arrangements where they are not together. So the number of arrangements where they do not sit together, we are going to say the total number of arrangements, that is our 13 factorial. We remove those number of arrangements where they are actually seated together. Then our answer will give us the total number of arrangements where they do not sit together. All right. All right, everybody, this is your interactive activity. I just want you to try this exercise and drop your answer on the comment section. Then I'll just comment from there if you got it correct or not. Okay, it says there are 5 boys and 5 girls to be seated in a row of chairs. How many different arrangements are possible if the boys must not be seated next to each other? Okay, obviously here you have to be remembering what we learned in this lesson, the not rule, where obviously we realize that we can't count this number of different arrangements at the same time. We do it indirectly by actually going to the total number of arrangements that we would have counted. Then we remove those where these people are actually seated together. How do I know? I have to use the not rule, by the keyword in the question, must not be seated next to each other. Hence we call it the not rule. Okay, I hope you find this lesson helpful.